Okay, so let's go on with our notes. So because these three are called direction cosines. Remember, if I ask you to determine the direction cosines, it means you need three values in your answer. Okay. If I ask you to determine direction cosines for a vector, you need three quantities. You need three values for the answer. Another point to note is that because these are cosine quantities, so what is the range of direction cosines of the valid direction cosines? What's the range of direction cosine? For example, cosine theta x or cosine theta y or x or y or z. So because it is a cosine quantity, it means the maximum value of cosine theta is the maximum value of cosine is 1. And the minimum value of cosine theta is -1. Very good. So up to now, we only talk about positive direction cosine. But what does it mean by negative direction cosine? If let me write it. Let me put a new page here. If so because cosine theta x, cosine theta y, and cosine theta z, the range of these three cosine values is between -1 and +1. So there are sometimes we have cosine direction cosine smaller than 0. So if cosine theta x is, for example, if cosine theta x is smaller than 0, what do we know about theta x? Very good. So one of our friends say theta x is larger than 90 degrees. Okay. And what does it mean on the graph? It means, for example, let's draw a 2D diagrams here. It means theta x is larger than 90 degrees, for example. It means the force is pointing. It means force is pointing. Oops. In negative x direction. It's okay. These direction cosines can be negative. This is okay. It means if cosine theta x is smaller than 0, it means theta x is larger than 90 degrees. Therefore, graphically, on the graph, it means theta x is larger than, this is 90, right? And then larger than 90 degrees, it means the force is pointing in negative x direction. It's okay for you. Oops, sorry. It's okay. Some of your seniors always write positive direction cosines. This is wrong. So some direction cosines can be smaller than 0. It's okay. So the our friends in room 105, okay? It seems so. Um, and let's move on and we go to the next page. Now we want to discuss another property. We still need a figure in we still need a figure. So if you are, of course, if you are using your tablet, you can copy this, but I want to draw it again. So I usually draw it like this X, Y, and Z. And we have vector D. And of course, we have, sorry. Let's draw a simple figure. And this coordinate, this one, of course, is 0, 0, 0. And this one is x1, y1, and z1. Or we have, sorry, you can say this is F. Let's assume F goes to from 0, 0, 0 to x1, y1, and z1. The next thing is, of course, I know drawing figures is not easy, but draw with me and your speed will you can draw you you will be used to drawing figures towards the end of the course. So we come to the next point, and let's have a look of the magnitudes. The magnitude of the force F is, of course, F, right? And this one is, of course, this is a scalar with F. So what is the magnitude of this term in the bracket? What's the magnitude of, oh, sorry, what's the magnitude of this three terms together. What's the magnitude? The length of this vector here. What's the length of this vector? Because the magnitude of force F is F. The magnitude of the left-hand side is F. This one is a scalar. Of course, its magnitude is F again. So to make this to make the product, you know products, right? If the product of this and this is F, so what is the magnitude of this part? 1, right? So the magnitude of this part is equal to 1. We learned if a vector has the length of 1, what is it called? This one is called a unit vector, right? In the direction of F. Is that okay? So because for vectors with the length of 1, that they are called unit vectors. So this is a unit vector because it is in a 3D direction along the force F. So it is a unit vector in the direction of F. In mathematics, we give it the symbol of this unit vector is lambda. The symbol is lambda. It's okay. From here, we want to know something else. We know that this one is equal to, the magnitude of this vector is equal to 1. So we can write, because this one, by the mathematics, you know that's the length of a vector. For example, for any vector f here from 0, 0, 0 to x1, y1, z1. This one is x1, and this one is y1, and this one is sorry, what I'm writing here. Y1, and this one is z1. Right? So what's the length of this vector f here? Let's have a look of this d. D here. D square equals to x1 square plus z1 square, right? This then f square equals to y1 square plus x1 square plus z1 square. I think you are okay with this, right? I think you are okay with this part. So using the same logic, 1 is equal to the square root of cosine theta, cosine square of theta x plus cosine square of theta y plus cosine square of theta z. Therefore, it comes to equation 2.24 on the textbook. Therefore, we have this relationship. Is that okay? So the point I want to make is this. Oh. The point I want to make is this, that theta x, theta y, and theta z are not independent quantities. These are not, if theta x, if we know theta x and if we know theta y, then we somehow we know what theta z is. We cannot pick theta x, theta y, and theta z, and we cannot pick random ones. We cannot pick any combination of these three terms, because if we know theta x and if we know theta y, the third term theta z is needs to satisfy this equation. It's okay. These three are, we call it, dependent on each other. These are related quantities. These three are related to each other. Is that okay? If we know theta x, if we know theta y, then somehow we know what theta z is. It's okay. So, and this is the point I want to make here. In the there are some equations below at the bottom of the page. These deal with how to add forces in 3D space, and I think you can do this. I think you can handle this. Concurrent forces means the forces which pass through the same point. Concurrent forces means different forces which pass through the same point. I think this is this the things down there should not be a problem to you. You think you can handle those? How much time do we have? Okay. So as always, if you have problems, understanding my class, you can first write things down and wait towards the end of the class, and I will repeat the points. It's okay. So, and let's go to the. I'll wait here for. I'll stay here for a moment. So for the next let's have a. I won't do everything on the next page, but let me give you an idea of what's going on here. And usually in engineering we don't know we don't know what cosine theta x, cosine theta y, and cosine theta z are, but we know one thing. We know the coordinates. Oops. We know the coordinates of points M and N. Oops. And we know the force passes through points M and N. Oops, sorry. Where are we? Sorry, I touched another. Sorry, wait a minute. Sorry, wait a minute. Where are we? Wait a minute. Oh, wait a minute. So we know the coordinates of M and N. We know the line of action. The line of action of F is passes through M and N. In other words, this direction is the direction of force F is in Mn in this vector in this direction. So we know something about the direction of F, but we only know the two coordinates, the 2 points in the space. We know x1, y1, z1, and x2, y2, z2. It's okay. But we don't know cosine theta x, cosine theta y, and cosine theta z. Of course, because we need those cosine theta x, cosine theta y, and cosine theta z later on. Later, we need those. So we want to determine this. We want to determine this based on M and N. Is okay. So in the let me begin with. I will complete this example on Thursday, but let's begin with this. We know, what do we know? We know the coordinates of M and N, right? M is at x1, y1, and z1, and N is equal to x2, y2, and z2. One thing to note. At high school, sometimes you in the mathematics class you mark vectors like this, but in our course and the other courses, this bracket can only mark coordinates but not vectors. Okay, but not forces. It's okay. For forces that it must be written in I, J, and K. It's okay. You can use this. You can use this to mark coordinates, but forces must be written in this form. It's okay. What's the English of these symbols? What's the English of these symbols? No, no idea. Anybody have any idea? Brackets. So we use brackets to. You can use brackets to mark coordinates, but not forces. Is that okay? So take some time to write it down, and I will show you an example. I think I should stop recording here and